Hi everyone. Today is December 7th, and we are here at the Patch Working Group meeting. Um, I'm reminding everyone that we should adhere to the CNCF Code of Conduct while engaging in this meeting. So, as I said, we have a packed agenda today. Let's get started with Aldo. In order to make sure that the meeting is efficient, I have provided co-host to the speakers already. If there's anyone else who needs co-host, please let me know. So, Aldo, over to you.
Thank you. Let me share real quick. Um, so I basically wanted to give a heads up about this proposal to the working group. Um, as we are, as you might know, we have this suspend field in the job API that allows Q to control when to start a job. And as we started thinking about workflows, think of um, job dependencies, Argo, uh, things like that, Argo workflows. As we start thinking about these topics, it quickly becomes obvious that the suspend field is limiting. So I started thinking about the idea of readiness gates, so that let's say if you start a workflow, you could create all the steps at the beginning, um, and then these steps have basically two readiness gates. Um, One of the readiness gates could be the workflow manager that as jobs complete, um, this readiness gate is removed, and then queue can act and start queuing this step. And once it's satisfied the quota and other semantics, it can remove the readiness gate, and now the job is allowed to start. So it's basically a generalization of the suspend field. Um, so I wanted to bring this to the attention. There has been already some feedback from the community uh, about other things that the readiness case might be useful for. Um, so if you have any other ideas, please contribute, please share. Um, there is also a mention of whether we should stop just here or we should already start thinking of a queuing sub-resource or something like that. Initially, we thought about it like as a suspense sub-resource, but it's more generally, um, I guess I don't know exactly which name it should have yet. But the idea of a sub-resource would allow any workload manager or a queuing manager to treat any CRD similarly through interacting through the sub-resource instead of having to implement a controller for each CRD. However, I don't think I have the bandwidth to do that. So if there is anybody that is interested on this topic, um, feel free to contact me. Maybe we can continue brainstorming the ideas. Um, and yeah,
Yeah,
there is. Sorry, yeah.
yeah. So I just want to say I'm definitely interested in helping and have like are you thinking about proposing a cap for 1.30? Is that the current thinking?
Um, Unclear.
Okay.
uh, maybe,
Okay,
but
maybe like we can, for other folks that might be interested, we can collaborate on maybe a draft cap on a doc and then kind of see if it lines up with the 1.30 deadlines.
yes, yes. Um, but just to finish up, I think there is present on this kind of mechanics. We have this same thing for pods. to prevent from scheduling. So it's kind of the same thing. And then again, we will have it for jobs. So maybe again, it makes sense to also make it a sub-resource. I see that Jordan is here. What's your take on a sub-resource? You're muted.
Sorry, I don't know. I hadn't thought about a sub-resource for this. Be interesting if, I guess the first question I would have was, would we consider this to be like a generic sub-resource like scale or status? Is this a pattern we would want to see applied to other things that have gates, readiness gates? That would be one question.
Yes, exactly. That will be the plan.
Okay. For things that have more than one type of gate, so we have readiness gates and scheduling gates on pods. I would wonder, like, would we have two sub-resources for that type, or would we have one like gate sub-resource where you indicate the type and the name when you're saying, I want to remove my gate? I don't know. Those are the types of questions I would have.
Okay. Yeah, I think the pod readiness gates or readiness, is it called gates? Whatever controls the readiness condition, right? That's what you mean? I think that's not what we are interested in here, because we are interested in queuing and stopping, starting. So maybe it would be, yeah, maybe we need to find a good name, because it doesn't really match.
Yeah, looking at the things that have gates today and seeing if which parts are in spec, which parts are in status, like what the flow is today for the things that want to modify the gates or modify the status of that gate. I think we do it with conditions, maybe. Just sketching out the flow end to end and seeing what is similar across the types that have gates and what would be similar across this type in terms of, would things need to touch spec or update spec or update status, and how would they do it today, and what do we want to constrain them to, and is there a common pattern that would make sense across these types?
Okay. I don't want to take too much time because the agenda is packed. But please share your feedback, everyone.
Thanks, Aldo. So let's move on to the next item. Kevin, hi. I think Kevin wants to talk about DRA.
Yep, great. Thanks. Yeah, I'll share my screen in a second. I just wanted to make sure that you also have given co-presenter or whatever it's called permission to Patrick, because he's gonna jump in after me. So
well, you can share the slides and I'll just talk.
Okay, and then you can just talk. Yeah, that works.
Yeah.
Okay, good.
Yeah, anyway, Patrick has co-host as well. So as whatever way you want to continue.
But it appears I've never shared my screen on Zoom before. So I can't do it quickly. Patrick, can you maybe pull up the slides and we'll do it the opposite?
Let's see whether I can do it faster than you. I'm not familiar with it either. But give me a second. I know where it is. I thought I did. No, I just need the slides.
Sorry, I dropped for a second. It looks like I need to be given co-presenter access again.
I'll do that.
So I might have shared the slides now. Does it show up for you guys?
We see your whole browser window.
That should only be the one window.
We're in.
Not that
I got it on. I got it on mine now, Patrick.
There we go.
Okay.
Now we
Yeah,
see.
Good.
Yeah. First off, let me just thank everyone for allowing us to present this at the working group batch meeting. So up until now, most of the work we've been doing on DRA, dynamic resource allocation, has been under the umbrella of Signode. And most of the presentations we've given and most of the conversations we've had have been on the Signode channel, not as much on the working group batch channel. But one of the reasons that we've now brought this to working group batch is that as we're trying to move DRA from alpha into beta, some of the challenges that we're facing with that are around the support we've built to integrate with both the scheduler and the cluster autoscaling components of Kubernetes. And so we thought it was a more worthwhile forum to continue these conversations in the context of working group batch rather than Signode, since representatives from both scheduler and autoscaling regularly attend this meeting, and a lot of the use cases that DRA will help unlock are relevant to the type of workloads you run in a batch setting. So this is just a quick update. I sent a bunch of links before this meeting that I hope a lot of you had a chance to at least sift through a little bit, because we're not going to go into great detail about what DRA or how it works. But we mostly want to focus on the challenges that we're facing at the moment with graduating DRA to beta and how we can overcome some of these challenges as a group. So what exactly is dynamic resource allocation? I'll at least give a brief overview of what it is. And in general, it's a new way of requesting resources in Kubernetes that's been available as an alpha feature since 1.26. It provides an alternative to the count-based interface of asking, for example, nvidia.com/GPU2. And I put the stress on alternative because we're not trying to do away with the existing device plugin API that allows you to have an extended resource like this. It really is an alternative. If you have complicated or complex devices and resources in general that you want to make available, you can use DRA to give you a much richer interface for getting access to these resources. And one of the ways that it does this is that it puts full control of the API to request resources in the hands of third-party developers. You're not limited to just being able to say, I want 2 of something or 1 of something or 3 of something. You can define the API for how you both select the type of resource you're looking for and how you might configure that resource for use once your pod that's consuming it lands on a node. And some of the key concepts to keep in mind whenever we're talking about DRA are that of the resource class and resource claim, which is very similar to the notions of class and claims in the persistent volume API. And these are in-tree APIs that exist inside Kubernetes that your pods can reference in order to get access to resources. And then correspondingly, each of these has what we've called a class parameters object, which really allows the third-party vendors to bring along their own specific API for, as I mentioned before, both selecting and configuring the resources once you've been given access to them. And the 3 talks that I've highlighted here, all KubeCon talks that we've given in the last year or so, where the first one just kind of gives an overview of what DRA is, how it helps improve the user experience for device consumption inside Kubernetes. The second one was a KubeCon talk I gave last April, which kind of teaches you, at least in the way that we've currently designed DRA, how you might build a device driver against the new APIs that exist, so that you can make your resources available for consumption using these resource class and resource claim mechanisms. And then the final one is a talk I just gave a few weeks ago at KubeCon North America, which really focuses on the use cases for GPUs. In this presentation and in the document that I sent out yesterday, I've kind of expanded on the set of use cases that I talk about in this presentation. But I encourage you guys to look through all of these. And if you're especially interested in GPUs, to watch this last talk, because I go through in detail what types of things DRA unlocks in the context of GPUs. Where the document that I prepared actually lists out every single one of these here as possible use cases that DRA unlocks that is not possible with the existing device plugin API. I really just want to, at least for the purpose of this talk, highlight the top two to kind of show you some of the power that DRA gives you with being able to access to resources in a way that's different than the existing device plugin API. And these two are giving you the ability to have some sort of controlled GPU sharing. So with the existing device plugin API, there is the ability to do some sort of oversubscription and get access to multiple GPUs from, or access the same GPU for multiple containers. But you can't really control how that's done in any kind of consistent way. And additionally, it's really hard in the existing device plugin API to have to select a specific GPU that you're looking for based on some complex set of constraints. And so I just want to quickly show an example of how these two things can be done with DRA today. Where the first one is just this simple notion of GPU sharing. So I didn't talk in detail about what a resource claim looks like, how those get consumed by pods, but hopefully this example is pretty self-explanatory, where on the left, there's a new construct called a resource claim, which references a resource class that I, as the developer of the DRA driver for GPUs, would have pre-installed on the cluster for you as a user to be able to consume. So if I create one of these resource claims, I give it a name, in this case, shared GPU, and I reference this resource class called gpu.nvidia.com, I can now take that resource claim and I can reference it in my pod spec the same way I would for something like a volume, if you're using a persistent volume claim, where the claim section that declares the resource that you want to consume is separate from the place where you actually consume that resource. So if I have this resource claim section in my pod spec, I reference this resource claim by the name shared GPU, I give it a local name called just GPU, and then I can reference that in multiple containers. And I know that under the hood, those are going to reference a unique GPU, the exact same GPU that's been bound to this claim when it gets allocated by my driver, after coordinating with the scheduler and everything else in Kubernetes. And additionally, it's not just limited to doing this from within a single container or a single pod across different containers. You can, as long as both of these two different pods have access to that claim, they can both reference that claim, and then even across pods, you can get access and share access to a GPU. And the example I've shown so far only really show how you can use one of these claims, which is the in-tree API for how you reference one of these resources. But the real power of DRA comes from the fact that I, as a vendor, can bring along my own API for how I can do selection and configuration of these GPUs once they land on a node. And this is how that looks. So if we take the resource claim on the left and we expand it with this new section called parameters ref, I can reference a separate object, which is defined by my own vendor-specific object that I want to add to Kubernetes. In this case, I've called it the GPU claim parameters object. I define the spec for this and all of the things that are associated with that, so that when I write my device driver for DRA, I know how to parse this information that's contained in this parameter spec and find a GPU somewhere in the cluster that matches those constraints. And this is all from kind of the user's perspective. How would you actually consume resources given this DRA driver for GPUs? But under the hood, what's actually happening is you've got, if you actually start on the right of this picture, any one of these resource drivers that you write consists of two separate components. There's a centralized controller, which you would run either as a replica setter one or somewhere under your control plane. You'd be running the centralized controller, which knows how to communicate with the Kubernetes scheduler. And then on any node that has GPUs, you'd be running a kubelet plugin as a daemon set that knows how to both advertise all of the GPUs that are available on that node, so that the centralized controller can become aware of them and eventually allocate those GPUs to pods that are requesting them, as well as be able to inject those GPUs and anything else that's necessary to make use of those GPUs into a container at runtime after a pod has been scheduled to a node that contains the GPUs that the centralized controller is allocated to it. And kind of the main purpose of this slide, and why I want to, at least my part of this talk real quick, I want to end with this slide, is that this is one of the pieces that is currently kind of under discussion in DRA that's been keeping us from graduating to beta. And the reason it's doing that is that, until now, the Kubernetes scheduler is typically only kind of a read-only, it operates in a read-only fashion, right? It reads a bunch of information, it makes a decision on where a pod can land, what node that will land on, and then it schedules it there. But with the introduction of DRA, there's actually this back and forth that needs to happen where the scheduler calls out to some completely separate component, communicating through the API server where the objects are being written and read back and forth until a pod is actually found where a resource claim can actually be allocated and the pod can run. And there's this back and forth going on, which would slow down the pod scheduling. And so one of the things we need to discuss as a group is how we can improve this situation potentially, or if it's actually not that bad given the types of workloads that we plan on running and making use of these resource claims. So that's the background, and I wanted to kind of pass it over to Patrick now to talk about some of the more specifics of where we are and how we can move forward.
Yeah, so before you move on, it's worth pointing out that the cluster autoscaler also uses some of the same code as the scheduler, but it doesn't have the luxury of actually communicating through the API server, because while the scheduler can do updates in the cluster, the autoscaler is really just read-only. It can't interfere with existing objects because those are the ones that are in use in the cluster by the autoscaler and by the DRA driver controller. So that's where we are currently really running into a problem with this strong aspect of DRA. It's an advantage that we have opaque parameters, but it is becoming a problem when we are trying to support the cluster autoscaling aspect. And in that summary document and on the Slack channel, I started drafting or summarizing the options that we have. We basically could do something like the scheduler plugins with building logic provided by a vendor into a custom autoscaler binary. That's one option. We could do something like scheduler extenders, webhooks, or some other gRPC mechanism where the cluster autoscaler calls out to driver code. But both of these have drawbacks. Concerns about performance is coming up again. So what I ended up drafting as a proposal in that document is what I call numeric parameters. I think it's becoming clear if you look at the alternatives that there really isn't a single solution that gives us both opaque parameters and autoscaling. You can't have your cake and eat it too. So I hope that with numeric parameters, we kind of meet in the middle. The idea here is that instead of completely vendor-defined parameters that the scheduler and the autoscaler can't do anything with, we introduce some kind of standardized, or essentially not just one, but perhaps a model that describes hardware in a kind of generic fashion. And then DRA driver vendors can opt into using those numeric parameters instead of providing their own. And if they do that, and we also add support for these numeric parameters, we get a bit closer to traditional device plugins in the sense that the DRA driver just runs on a node. It publishes some capacity for this numeric model. The kubelet publishes that information, and then code that is built into the scheduler and the cluster autoscaler interpret those parameters pretty much like they do now with the extended resource parameters. And if we do that, we get faster scheduling because it is the traditional model where the scheduler makes the decision based on what it knows about the cluster state without consulting with an external controller. We get autoscaling, full support for scale up, for scale down, because the built-in code also would be able to simulate the effect of scheduling a pod and allocating a claim or later deallocating it. So both of these operations would work. The design doc, I actually started thinking about this a lot in that summary document. You will find a whole appendix where I'm drafting up a potential API for it. But that's, at this point, an idea. And I want to toss that out here to see whether that would be a good middle ground that defines agreements among interested parties to see whether this is the way to go with cluster autoscaling. It's also worth pointing out that not all use cases for DRA need autoscaler support. To verify that, in that summary document, we also started collecting use cases for DRA from people who are actually working on DRA drivers right now for specific scenarios, specific kinds of hardware, specific customers that they have in mind for their products. This was partly to reevaluate also the design choices that we have made so far. And I think it's fair to say that, at least the people that we got to comment on so far, strongly lean towards just keeping DRA as it is right now. Either they don't need autoscaling, or they see the plug-in model that I mentioned earlier as a viable approach for them. So I think if you go through the use cases, I think it's a fair summary that, yeah, we should go ahead with the current DRA, but then need something for cluster autoscaling for those folks who want it. For this audience here, next steps for beta are to collect feedback from the DRA driver developers. We started that, but now the document is open. I welcome everyone to add their own ideas, ideally after making yourself familiar with DRA so that you can answer a few questions that I have in that document about the way how you want to use DRA. And then if we think about GA at a later point, when there actually are DRA drivers available to customers and users, we also will have to have feedback from users, but that's further out. Right now for beta, I think we just need DRA driver developer feedback, and I think we do have enough of that to hopefully make a decision for how to proceed in 130. With that, perhaps let's go to the next slide.
One question, Patrick.
Yeah.
So
okay.
when you refer to cluster autoscaler, are you specifically referring to horizontal pod autoscaler in terms of scaling the number of nodes within the cluster, or are we referring to vertical pod autoscaling as well?
The horizontal.
Okay.
It is about adding nodes and removing nodes in the cluster where the support for dynamic resource allocation becomes important, because for node local resources like a GPU, it makes a difference whether you add or remove a node. It does not matter for something that we haven't had in the presentation, where a DRA driver manages a network attached resource, which is also possible, but it is relevant for most of the use cases that we've been discussing so far, where a resource is local to a node, some piece of hardware that gets added or removed together with a node.
Thank you.
So we talked, Kevin mentioned scheduling performance. So that also is one of the questions that we had when we started collecting use cases. How quickly do you need your pods to be scheduled? That's one thing. I think the answer mostly is we don't care. Our hardware is too expensive to initialize, so we will reuse initialized hardware anyway, and pods will be long-lived. That's one thing. The other concern was that scheduling pods using DRA currently do blocking API calls. I think that can be addressed. It's an implementation detail, and I have PRs almost ready to be merged early in the 130 development cycle. So I think we should be doing that. Get those PRs reviewed and merged. That will be basically a solution for the problem of affecting other pods in the cluster. And then I'm leaning towards having a separate cap for what I described earlier as numeric parameters. It is basically a follow-up cap in the sense that it works within the framework established by the current cap and just changes some aspects of it. What are the parameters? How are they getting handled? Yeah, Aldo has a question, but yeah. Go ahead. Let's address it right away.
I am concerned. So you're saying that maybe we can proceed with the existing model to beta, but I would be actually against that until we have an alpha for the numeric model, because it could be the case that once we have this alpha model, we actually realized that we don't need the other one.
Yeah. So
And
that's also that's exactly my last point. I would make the promotion of core DRA to beta conditional and on having these numeric parameters implemented, available, evaluated, and I would not proceed further with core DRA unless we are relatively confident that these numeric parameters are available and can be tried out. So yeah, I'm on the same boat. I think we are on the same page here. This means that this cap must get done fairly quickly, but I do have enough material and I thought enough about it that I think I can draft a cap for review in the 130 development cycle. And then the implementation also isn't that hard. So I think it's doable to do that in 130. And then at the end of 130, we can make the final decision on whether the core DRA can be promoted or not.
Yeah, I think Aldo, the one subtlety Aldo was saying was that he wouldn't want core DRA to go to beta in 130, even if we had numeric parameters available until we've had a chance to play around with numeric parameters. And I think that's what I heard, Aldo. Is that correct?
Yes, so no beta for existing DRA until we have finished, and until we have a working alpha that has been tested by people. So 2 releases at least.
Tested in a real release, you mean? Okay, well, that's different from being it available in master and people trying it out. But yeah, I get your point.
I think we're in agreement that they, in theory, could have 2 separate graduation cycles. So numeric parameters graduate separately from core DRA, but the earliest core DRA could possibly go to beta would be 131, if what we just said holds.
If anything, yes.
I see we have a bunch of raised hands. Marcin was the first one, I believe.
One comment on the numeric parameters. So I guess they are not only for cluster autoscaler, but they will also improve the throughput in scheduler itself. Like if there is no need for external communication, then numerical parameters would make it quicker.
That's correct. Yes. And it's also important that the scheduler and the autoscaler agree on the interpretation of a parameter. So you can't do one thing with a scheduler and then something else in the autoscaler, because then there's a mismatch.
Okay, and if both scheduler and cluster autoscaler would be better off with numerical parameters, what are the remaining use cases for the core thing, and why would it make sense to promote it to beta?
Because there are use cases that don't fit well into numeric parameters and don't need autoscaling. There are deployment scenarios for Kubernetes where you can't create nodes, for example, Kubernetes on the edge. And those are scenarios where the current approach works very well and provides the flexibility that people need.
So in fact, we are talking about 2 types of DRI, one with one core and one with numeric that could potentially offer slightly different functionality.
It's the same DRA internally, or well, it's core DRA the way how it's currently described, and then there is additional code that gets activated in and takes over for the vendor controller when using numeric parameters. So I wouldn't call it 2 different DRAs. It's additional aspect of mostly the scheduler plugin.
Yeah, I think a good way to maybe describe it is that, I mentioned that there's the 2 components of the DRA driver. There's the centralized controller and there's the kubelet plugin. Basically what would happen is that if, a class opted in to being governed by numeric parameters, you'd have to somehow indicate that in your resource class when you install it. And that would trigger the scheduler and or autoscaler to know that it should follow that path of using numeric parameters. They would never make a call out to a controller. You wouldn't even need to implement a controller if you only cared about numeric parameters. And And then all of that would be internal to these components. But if your resource class indicates that it wants to bring along its own controller, where it would be a bit slower and there'd be this back and forth with the scheduler, you can do that. It's just that you'd have to indicate that in your resource classes. So numeric parameters becomes kind of a base case. If you know that everything that you're doing can fit into numeric parameters, then you don't have to burden yourself with writing one of these controllers. But if you can't, then you still have the freedom to write one of these controllers with the knowledge that cluster auto scaling may not work and pods may take longer to schedule by the scheduler.
Okay, thank you for the answer.
I believe Todd was next.
Yeah. So for the numeric parameters, I guess just to start, really interested in the auto scaling scenario. So I built a Carpenter scheduler, and so sort of having a priori knowledge of what the node is going to look like is super important to be able to launch the correct node. We've got 700 plus instance types. But for the numeric parameters, have you looked at reusing the match expressions to be able to match against those parameters and maybe expand it to support like floating point comparisons instead of just integer? And it's something users are already accustomed to, and there's already a match expression language within Kubernetes instead of building something else. And if so, does that sort of reduce the amount of time required to implement numeric parameters?
So my thinking here on numeric parameters is that it's more like a framework for defining resource models, and what exactly the numeric parameters will look like is kind of open, and I want to keep it flexible. I know of one prior effort to standardize resource descriptions. There's a Google Doc floating around, I think it's linked to in the original CAP, where people tried that several years ago, and they got completely bogged down trying to define some model that is so flexible that any future hardware can be described with it, that they never really fully finished the mission and gave up at some point. With the current approach, I'm more interested in having a framework where it's very easy to define another numeric parameter type. And if we find that one that may go into that cap is too limited, it would be very easy to have another cap that says, here's my numeric parameter type for this kind of hardware. And that what you just described may be one of those options. Perhaps it's even a better option than what I have in the current document. So yeah, it's worth looking at that. But I want to point out that it's not critical to get this right immediately, because it should be very easy to change that afterwards. We want versioning for these parameters so that different users can choose different types by kind and version. And the only requirement is that what they are using must be something that's understood by the scheduler and the autoscaler.
Okay. Yeah, I just want to, as you're thinking about it, like look at match expressions, see if it works for you. Because it's pretty expressive and useful for a lot of other things. So it'd be nice if we were easy. Thanks.
I believe Jordan is next.
There were a few things that I was thinking. I think the idea of meeting in the middle, where we have sort of a set of information that the scheduler and autoscaler understand directly, so non-opaque parameters, and then an optional second step where it's a call out that only the vendor stuff understands. I think that makes sense. The numeric piece I like the sound of. I was also curious if selector information made sense to include. So I think right now, selector information from the pod gets carried into the scheduling context and handed to the vendor call out, or the pod scheduling context object. So the vendor has that information, but I didn't see a spot to tell the scheduler and autoscaler this resource claim or resource class has these node selector constraints.
The resource class has a node selector.
Does it?
Yes, it does. It's
Okay.
exactly for the use case where the vendor knows that his hardware is only available on nodes with certain labels. So it's a prior, it's taken into account by the scheduler plugin when it chooses nodes.
Okay.
Because basically it filters out the nodes that are definitely never going to have hardware for that claim.
Okay.
So that's already in place.
I missed that. I got.
I think we need to make that more powerful, because I saw that you have use cases where you want to select a specific driver version, and that cannot be expressed with no selectors. But also it's easy to simulate, like not numerically, but some kind of matching model.
Okay, so we have a spot in the API where we have node selection capabilities. Looking at whether there is an opportunity to make that more powerful seems like a useful thing to at least check, but there is a place in the API for that already, so that's good. In terms of rollout, I think the things that scheduler and autoscaler understand inherently, so the node selection information and the numeric resource information, we need to make it really clear that anything that can fit into those criteria is preferred for performance and autoscaling capabilities. I think what will happen if we release DRA as it is today is that we will get a bunch of drivers doing everything opaquely. And then if we add the ability to do non-opaque numeric parameters later, uptake of that will be slow, and we'll be stuck in a spot where most early adopters or most drivers do not support the performant auto-scaling compatible numeric parameters that we actually prefer. This reminds me of stuff that happened with CSI, where optional capabilities were added to the CSI spec later, and drivers had to choose to opt into them, and uptake was slow. And some of the speed and optimization and user experience improvements that got added to CSI later just took a long time to get picked up by drivers. So if I would really push to have the things that let us do this performantly available before we start encouraging drivers to do a bunch of integrations.
So that's another argument in favor of having the numeric parameters as alpha in 130 and DRA as alpha in 130, and then later decide about how to move forward.
And to be clear, I like the idea of being able to use them in combination. Like, have the selector and the numeric stuff as a pre-stage, and then for drivers that need to do complex things that you couldn't express, have that as a second stage. That seems useful.
I know people who will not be happy about this because they have been waiting for DRA to reach beta, but I guess we'll cope. It's not entirely unexpected. I was just really seeing what the response would be to this proposal to see whether it could fly. But yeah,
I think the last question that we talked about in Chicago, and then I'll let other people talk, was the failure path or the user experience, like the visibility when the opaque vendor call out fails, like just making sure that recovery is as reasonable as we can make it in terms of surfacing why a thing didn't work.
Yeah, we've been discussing a bit among ourselves how far up the chain we should publish events, for example. So right now it's a bit like everywhere in Kubernetes. You have a deployment, creating pods. A pod depends on a resource claim. A resource claim needs to be allocated, and you need to follow that chain to look at the specific claim to see the events of, say, allocation attempts failing. And I think one of the changes that we did already make is that if it's clearly a claim that is related to one pod, that the same event gets also published for the pod. So if you do a kubectl described pod, you will see events coming in from a failure in a DRA driver that tell you something about why allocation isn't moving forward and why the pod isn't getting scheduled. So I think it is a little bit better already. I'm not sure how far up we should go. Pod seems reasonable because it's an understood concept by the pod scheduling context handler. Anything further up, the job or other app controllers are probably going too far.
The other thing we talked about, not in too much detail yet, I guess, but was having a distinction between transient failures and permanent failures, which right now there is no real distinction between those. And so you don't know if, it's something you put in your pod spec is causing this to never be scheduled, or if it actually is just something transient and you need a node, you're just waiting for a node to become available.
Yeah, we definitely need to distinguish between terminal and transient.
Yep.
Because like in the one, you need to kill the pod and like go completely out and start again. And the other is like, just wait for it, wait.
Yeah, exactly.
Yeah.
Yep.
Okay, a quick time check. I believe we are almost past our time. I will give Abhishek the opportunity to ask the question and we'll have to call it a meeting. I apologize in advance to Patrick. Maybe you can record your demo and share it on Slack, or we can move it to the following meeting. So maybe Abhishek, if you want to go ahead with your question.
Yeah, thank you, and great presentation. So from the presentation, I understand the mode that was described and the discussions that we are having is for wait for first consumer. I want to ask or get a little bit know-how from the community. Do the same bottleneck exist for allocation mode immediate?
I think the use cases for immediate,
Go ahead.
The immediate allocation is, I think, it's not exactly being used much. I think it's there for symmetry with volumes, and we have some use cases that are depending on it, where allocating a resource is more important than actually scheduling a pod that uses it. I think it's actually for even longer lived resources that really are so central to the cluster that you just set them up once and then you reuse them multiple times. But I think, Kevin, you can better answer how you intend to use immediate allocation, if at all, with NVIDIA GPUs, for example.
Yeah, no, exactly as you just described. If you know you have a specific GPU in our case that you want configured a certain way, and you have lots of different pods that will eventually want to consume that over time, and the set of nodes you have in your cluster are pretty much homogeneous, then you can do this immediate allocation, get that GPU prepared, and then stream a whole bunch of pods over that GPU and reuse it over and over again without having to reallocate that claim.
And that would reduce the bottleneck that we are currently talking about, right?
Yeah, because there would be no back and forth with the scheduler. That claim would already be prepared. The scheduler would notice that and then just schedule the pod immediately, because it only has one choice. It has to go to the node where that claim's been allocated. And if it can't, then it needs to leave that pod pending until something happens that will allow it to land on that node. Something frees up.
All right. Thank you.
Any closing remarks before we finish up with the meeting? Patrick, Kevin?
No, the only thing I see, there's 19 messages in the chat. Let me just export these real quick before we close the meeting so that we can answer them offline.
And perhaps if you have questions that haven't been answered, go to the batch working group Slack channel, and then we can discuss them there.
Okay.
Sorry, I couldn't keep an eye on the chat. Anyway.
No, I got it on. I saved it here locally, so I can pull it up.
Perfect. Perfect. Thank you everyone for joining. See you all in 2 weeks. I will create a Slack thread to discuss if we want to have another meeting or we want to close for end of year, but we'll know soon. Thank you very much.
Thank you. Bye-bye.
Thanks.
Bye.